And now we're finally looking at the other measures of dispersion we haven't discussed yet, which are standard deviation and variance. So a more close definition about them and how to use them, how to interpret them. Have a go with the starter. So you're meant to find the central tendencies and then discuss what other ways you can distinguish between the two groups. We've done a similar activity before, but you could closely have a look at this one also. So the measures of dispersion, as we've outlined before, there are three main ones. So we have the range, which takes the maximum minus the minimum. The interquartile range takes Q3 minus Q1. And now we're going to look at standard deviation. Now, standard deviation is the square root of the variance. So if I have, we sometimes find the variance, and then when I square root it, it gives me the standard deviation. So we mainly use the standard deviation, but we sometimes rely on the variance also. We prefer the standard deviation because it gives us the number in the same unit as our data. We'll talk about that a bit more. So what's the idea behind standard deviation? So, okay, I found the range, I found the interquartile range, but they still didn't give me all the information about the spread of my data. What standard deviation does is that it tells you how far on average your data is from the mean. So imagine if this is your mean value and you have all your other points. And what it does is it finds the distance between each point and the mean, just the distance between them, and then takes the average distance of that. So it tells you on average how far the points are from the mean. So obviously, the bigger the number, it means you have the points are further away from the mean on average, and the smaller the number, it means the closer they are to the mean. So these are the formulas. We will break them down a bit more so you understand how it's done. This is how it looks like in the data booklets, by the way, for the IB Math AA. As you can see for the variance, there's a different version to it, and sometimes it's useful for some algebraic question. They can split the formula into finding the frequency times the x value squared divided by n minus the mean squared. So just to identify how this is a bit different from this formula. But obviously they give you the same values, but sometimes what happens is you have the x squared value. So we use this, we divide it by n, and we subtract the mean squared. So this is the definition. As I've mentioned, the standard deviation gives the mean average of the distance between each data set. The variance gives the mean average of the squared distance between each data set. So it's squaring the standard deviation. And you will be expected to use the GDC to find the standard deviation. You're not expected to do it by hand. And unless in certain cases where, for example, they give you the value of this numerator and then you have to divide by n and square root, for example. Where do you find it? You find it in the one variance stat. So if you put your numbers in L1, and if you have the frequency in L2, you do the one variance stat. The capital S gives you what we call the sample standard deviation. We'll talk about that later. And the sigma here gives you the population standard deviation. If the question is not clear about which one you have to use, the default one is the population standard deviation. So you will mainly focus on this one. But for now, just notice how the numbers are slightly different, where the sample standard deviation is a bit higher. We'll talk about that later. So you can practice with this data set. Try and find the standard deviation of this, put it in L1, and then go to one variance stat, see what you get. Just make sure that everyone's getting the same value, or you can check online also to check that you're getting the same value. So a very standard procedure here. So visually, just to understand how the standard deviation, you can interpret the standard deviation just from a visual sense. So if I give you these three data sets and I give you these standard deviations, so as I said, the higher the number, it means the average distance from the mean is bigger. And if we look at data set 3, you can see the numbers are very further apart from where the center would be. So you can assume this is data set 3 here. And the more concentrated data, which is data set 1, the distances are much smaller. They're more concentrated. So this would be data set 1 which leaves us with data set 2. So it's all about how spread out the data is, but in a more sophisticated process. So how do we actually use the formula? Now, suppose we have we want the variance of 32 test scores. So I have all these test scores. So the main first step is to find the mean. So notice the formula, it includes the mean here. So I will first find the mean, and then I will calculate the distance of each data from the mean. I will take the data set minus the mean, making sure I'm consistent. So I will do that for all my data sets. But then because I'm getting negative numbers, this will impact the summation. And we will not use the absolute value function. We'd rather just use a more mathematical method rather than a piecewise function. So what we will do is we will square these values in order to make them all positive. So we end up with these values. So we are done with the first part. And then what the formula tells you is that you need to add them all together. So we have to add all of these together, and then we divide by n, and that will give us the variance. So adding them all up will give me 198 over 32, which is 6.19. This is the variance of the data. And if I want the standard deviation, I will square root the data. So this is where we prefer the standard deviation, because as soon as you square the data set, it becomes, so this is a test score, but now this column represents the test score squared, which means 6.19 is not the same unit. Imagine if you're dealing with meters. Once you square it here, you're dealing with meters squared. So in here, you're dealing with some meters squared. So that's why we square root the variance to get the standard deviation so that the answer is in the same unit as the data. So the standard deviation is 2.48, which is quite a small number. You can see the data is more concentrated. They're not that further apart, which is, you can see that from the raw data. And again, you're not expected to do this by hand. You will be expected to use a calculator. So you can practice questions on standard deviation here. And for question 2, this is what I'm talking about regarding sometimes you will have to do it manually or use the alternative formulas. So they've given you the sum of f, the sum of fx, the sum of fx squared. And this is where you have to use the alternative formula for the variance possibly. So you can see the sum of fx squared here divided by n minus the mean. You recall how to find the mean squared. So you can use that to find the standard deviation. So this is a nice example to see how you can alternatively find the formula. And then the other questions will just ask you to find the standard deviation in a routine procedure. Now, talking about population and sample. So once you're done with the questions, just heading to this next section. What happens when you don't have the whole population? How accurate is the standard deviation then? This is when we start to consider, okay, I'm dealing with a sample rather than a population. So what we do is we adjust the formula a bit more, and we assume that we take the number of samples, but one less. So we subtract one from the sample size. So the purpose of this, it's called the unbiased estimator of the population, is that by lowering the sample size by one, we compensate for the fact that we are working with a sample rather than the whole population. So this is what it would look like. It's the same formula, except for the denominator. It's now n minus 1. So this is called Bessel's correction. And we call this new formula the unbiased estimator for the population standard deviation. So if you have a sample and you want to make predictions about the population, we use this formula. So this would be a good example. We're all asking for the unbiased unbiased estimator. So you can use the formula to find the values. Now the formula is not given in the data booklets, but you just need to know that it's n minus 1 in the denominator. So all of these are, you need to find the sample with you need to use the unbiased estimator of the population standard deviation in these questions. So have a go at that. The final thing we'll discuss in this lesson is the transformation of all the values that we've calculated now that we're done with mean, standard deviation, and variance. What happens if my data changes? This is a very important section in this lesson, and we will use this throughout different distributions later on when we do a probability distribution, for example. So if you have a data set and you have the mean of the data set, you have the variance, you have the standard deviation. If each of the data set's values have changed, and they would change through different methods, then the mean, variance, and standard deviation would also change, and sometimes unchanged based on what you're doing. So if you are adding or subtracting a number from every data value, so let's say you have test scores and then you decide to add a +5 bonus to all the students, so you're adding a 5. Or let's say, oh, you eliminated a question from the test, so you are subtracting a 2 throughout. So you're adding and subtracting every data from X. What happens is the mean will also increase or decrease by that value. So if your mean is 5, it's now going to be 5 plus 5, which is 10, for example. We'll look at examples later. However, the variance and the standard deviation doesn't change because imagine the whole data has been shifted up by 5, for example, if you added 5 to every data value. The whole data has shifted by 5, but that doesn't mean the distance from the mean has changed. So they're all still at the same distance, but the mean itself would change by a +5. Now, what if you multiplied by a value? And when we say multiplied by a value, we also take into account dividing by a value. So dividing by 2 would be the same as multiplying by 1/2. So when you multiply by a value, the mean will also multiply by that value. The variance will multiply by that value squared, and the standard deviation will multiply by that value also. So it will change because, again, think of the data, think of its multiplying, so increasing. So the distance will increase also, and the mean will also change. If you have a combination of those two also, then you would have a combination of those. So if you're adding and multiplying, then the behavior would also change. The variance would not change from the adding, but it will change from the multiplying. So let's have a look at this. So a data has a mean of 14, standard deviation of 4. If each of the data set has 10 added to it, find the new mean and standard deviation. So if I have a mean of 14 and the new mean will be the old mean 14 plus 10 added to it. So the new mean is now 24. But the new standard deviation, because I'm just adding values, the new standard deviation will not change. It will remain as 4. Now, what if each data set is multiplied by 5? So in this case, the new mean will also multiply by 5. So I get 14 times 5. So I get 70. And then the variance, be careful here, the wording is tricky. The old variance is the square of the standard deviation. So the old variance is 16. And now I need to multiply 16 by 5 squared. So the new variance is 16 times the thing that you multiplied by squared, which is 400. Or alternatively, you can find the standard deviation times the value. So it's going to be 4 times 5, which is 20. And then this is the new standard deviation, which means that the variance is going to be the square of that, which is 400. So you still get the same value. Now, if it's a combination of two, you just have to be a bit more careful with how it's done. So for example, if it says it's 5 times x plus 10. So if I'm combining the times 5 and the 10, then the mean would also be, the new mean would also be 5 times 14 plus 10. The standard deviation would just be the 5 times 4 without the plus 10. So just noting that the plus 10 doesn't impact. However, if the order is a bit different, if I say I'm adding 10 to my data and then multiplying by 5, then you need to go with the same order also. So the new mean would be 14, add 10 to it, and then multiply by 5. However, the standard deviation, again, I know I have to add by 10, but that doesn't impact, so it's just the times 5. It will stay the same, but just be careful with the mean. It will give you a slightly different answer. So the order matters in this case. So have a go at some practice questions with that on how the data changes. And again, this is an important concept that will continue later on in other probability distribution questions. So just a note at the end, if a question is not clear whether you have a population or sample, then you use the population standard deviation from the calculator.